The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. Welcome to this afternoon's research results presentation. This is Victoria Beal with the Ohio LTAP Center, and I'm very pleased to have with us Professor Bhavin Naik from Ohio University, who's going to be presenting on intersection modifications using mini-modular roundabout methods. This is a final research results presentation, and we are hopeful that you will have lots of questions. So please find your question box, and if you haven't used it in the past, just drop me a hi or hello in there so you can see how it works. But please feel free to put questions in at any time during the presentation, and Bhavin will be stopping periodically to ask for your questions so he can respond. So I believe that is all. Oh, I did want to mention there is also a copy of the presentation in the handout box, and we are attempting to record the webinar. If we're successful, you'll get a link to that recording when we complete. So Bhavin, are you ready?
Yeah, I'm ready, Victoria. Can you hear me?
Yes.
Okay, good.
Thanks.
A very warm welcome to everyone. Thanks for joining us in this final results presentation. This was an ODOT project that ran through Ohio's Research Initiative for Locals program, ORIL, and it was titled Intersection Modifications Using Mini and their Modular Versions of Roundabout Methods. I was the PI, Bhavin Naik, from Ohio University. We have a couple of other co-PIs on this, Kakan Day from West Virginia University, Jeang Wu from Cal Poly Pomona, and then we had a couple of grad students help us with this, Amit Kumar Roy, Amdad Hussain, Alexander Baki. We also had another faculty from Ohio University, Dr. Benjamin Sperry, on this project. Victoria said, throughout the presentation, as soon as I go through some of the results, I'll wait for a bit, get some questions, answer them, and then I'll carry on with the presentation. So please go ahead and put your questions in there. So this is just an abstract of the entire project. Thanks to ODOT, they funded this, as I said, through the Ohio's Research Initiative for Locals program. In this presentation, I will cover the findings and and a lot of the insights that related to planning, design, operation, and maintenance of mini roundabouts. Now, when I say mini, I also include the modular versions of them. The only specific difference that's there is the material type that they use, and of course the way it's constructed. So I'll just keep using the word mini more than the modular version of it. So as I chatted about the people on the project, we had folks from Ohio University, West Virginia University, and Cal Poly Pomona. So there's 3 different institutions that worked on this project. I'd like to acknowledge the Technical Advisory Committee members for all the insights and all the guidance they gave us as we moved through this project. Special thanks to Michelle Lucas from ODOT for managing this whole project. With all the COVID stuff and everything, she did a great job in helping us through the whole project. Thanks, Michelle. We had a couple of graduate and undergraduate students involved at different aspects of this project. And then we did a survey of transportation professionals, engineers, and other stakeholders. I'll share the results of that survey, but I'd like to thank them, and then also people that participated in the driving simulator experiments that were conducted here at Ohio University. So in terms of a background, I'm sure all of you have seen these type of statistics before. We have had 1.3 million fatalities, just road traffic crashes of all types worldwide. Here locally, we're on an average about 40,000. So 38,680 traffic fatalities in the year 2021. We've seen these statistics, nothing new, but I just want to remind everyone and bring context to why we were doing this intersection-related research. Most of these fatalities, if you look at the slide here, are involving an intersection. And they're bouncing around 9,000 and 10,000 crashes, fatalities every year. If you talk about the actual number of crashes which don't involve fatalities, we're talking about a higher number than that 10,000 value. So aware of this plaque or this plague, road safety initiatives have been established primarily to stabilize and reduce the number of these crashes. And moreover, the idea is to work towards a zero fatality goal. So when we're talking about intersections, we're talking more of a solution in terms of geometric modifications, okay? And when we're talking geometric modifications, we're specifically looking at converting two-way stop-controlled intersections or all-way stop-controlled intersections to modern roundabouts. And this has been the growing practice here in the US. We are moving from stop-controlled to roundabouts. And I'm certain a lot of folks on this webinar today have worked on projects involving this sort of conversions. So when we talk about converting to modern roundabouts, you've all seen the good things and the benefits that have been marketed with regard to roundabouts. Safety improvements, they're greener, low emissions, low noise, we don't have backups, and in terms of operations, there's less delay. All this stuff you see on this slide, we've talked about them in terms of traditional roundabouts. Okay. In fact, because of those benefits, we've seen a rise in the adoption of modern roundabouts here in the US. From 1990 to about 2016, we had about 4,200 roundabouts installed here in the US. Today, 2021, we're actually talking about 7,900 roundabouts. Now, I'm getting these statistics from a database that Kittleson and Associates have. So I think it's inclusive of all the minis and all the different versions of roundabouts. But then when we talk about these modern roundabouts, we are gradually seeing, I use the word decline in implementation, but I would rather say people are looking at alternates. And alternates to modern roundabouts are being considered primarily because of the high initial construction costs that are associated with the traditional roundabouts. They're expensive in terms of the physical construction, as well as the delay in traffic. You need to shut down the intersection for the construction period, and all those costs add up to the initial construction costs. The other disadvantage of modern roundabouts is in terms of navigation. Pretty much the smaller passenger vehicles, it's easy to navigate through these roundabouts, but when it comes to the high, heavy gross vehicles, emergency vehicles, those kind of vehicles, it starts to become a bit problematic in terms of modern roundabouts. Here's a case example right here where we are in Athens, Ohio. We have a 2-lane roundabout, and a paint truck spilled all the paint on the pavement. It caused an issue. I think for 2 hours there was concern within the community. There were no alternate routes, and it was all a mess. In addition, with larger roundabouts, we need larger right of way. So we'll need more land in which to build the roundabout. So right of way becomes a concern there as well. So with all these issues related to modern roundabouts, the problem exists for local transportation systems. What do we do at the county level, at the district level, at the village level, the smaller counties where budgets become an issue? So with limited budgets and restricted right-of-way, one of the viable alternatives to roundabouts, the traditional roundabout, is to use mini or modular roundabouts. And there have been implementations out there. There are some areas that have started to put these minis in, but there is very limited use, and only a few studies, research studies or pilot projects have been available. So essentially, there's no comprehensive study or any research report that can be used to plan, design, and implement mini roundabouts. So a lot of presentations out there, but nothing tangible where we can that we can use for the design side. So with that in mind, ORIL thought there was a need to synthesize and summarize the current research on mini roundabouts, and more importantly, to develop a mechanism that guides the local transportation officials here in Ohio on how to adopt mini roundabouts for the local Ohio transportation system. So overall, the goal of the project was to develop guidelines for ORIL to use on the installation and performance of mini roundabouts, okay, specific to the characteristics of Ohio's local transportation system. We had some specific objectives, examine the state of practice, of course, and then develop a synthesis of current research. We wanted to investigate the current practices. So what are people that have already adopted mini roundabouts, designed roundabouts, what are they thinking in terms of factors that relate to the installation of these roundabout type? Then with the idea that it is difficult for drivers to, one, understand how to use the roundabout. What are they going to feel if they see a roundabout with a smaller circular diameter? So with that in mind, we have a driving simulator here at Ohio University, and we use that to see what drivers feel with mini roundabouts. And then we also conducted traffic microsimulation analysis. So just to see the operations of mini roundabouts. And then with that, with the first 4 objectives in mind, we decided to help the DOT here with developing specific tools, a life cycle cost analysis tool, and also a multi-criteria analysis tool, which helps with the decision making on which type of roundabout do we place. Do we put a traditional roundabout? Do we put a mini roundabout? Or do we just leave it as a stop controlled intersection? So for this presentation, I'll just go through the first 4 objectives, how we, what method we used to come up with the results that targeted that specific methodology. So in terms of a methodology for the whole project, we had 9 specific tasks, and the ones highlighted in yellow are the ones that I will be discussing today through this presentation. You can definitely look at the report, the final report, and look at the spreadsheet tool, the multi-criteria assessment, and also the life cycle cost analysis for those interested readers there. So when we look at the literature review side of things, and also an examination of all the mini roundabouts that have been placed so far in the US, we compared all the guidelines regarding mini roundabouts and modular roundabouts at the international level. So we looked at what guidelines do the US have in place, what the guidelines do the UK South Africa, Switzerland, and Germany, and other countries have in place. Now, we did this specifically because mini and modular roundabouts are highly used outside of the US than here in the US. So their guidelines are in place rather than, they have specific guidelines already in place. In the US, we're still debating on the type of guidelines to implement. So we looked at the international version of guidelines. We also compared what Federal Highway have, especially in NCHRP 672, which is an informational guide on roundabouts. So we looked at that and then compared it with each state DOT's design guidelines and their design manual. What do they have in those design guidelines or manuals that are specific to mini roundabouts? So we looked at 27 out of the 50 state DOTs here in the US. 27 of the 50 have the same information that NCHRP 672 has, so nothing different. 17 state DOTs include some additional criteria beyond what NCHRP 672 has. And if you look at our report, we have all the different differences in the guidelines from these 17 state DOTs in there. And then we also examined all the in-service mini roundabouts. So thanks to Kittleson and Associates, they have a comprehensive database. We searched their database, took out all the mini roundabouts that are in place, extracted all the specifics of those mini roundabouts in terms of their design. What's the intersection inscribed circle diameter? What's the inner circle diameter? What's the width, lane widths? All that kind of information we extracted and summarized that in this literature and in-service examination. So in terms of findings related just to those syntheses, we broke them down into specific considerations, as in what conditions, traffic-related, roadway-related, or other, should be in place at the existing intersection so that a mini or its modular version can even be considered. So when we look at the traffic conditions, we're looking at a total entering intersection ADT ranging between 1,500 and 15,000 vehicles per day. This, in some locations, can go to a maximum of 18,000 vehicles per day, okay? When we look at the peak hour traffic volumes, we're looking at intersections where the range is between 1,150 and 1,400 vehicles per hour in the peak hours. Proportion of major and minor approach volumes should range about 60 to 40 between major and minor, or 70-30, okay? Truck volumes. When we look at truck volumes, we want them not to exceed a 3% minimum and at the most 4%. Okay, so you have anything more than 4%, you're not thinking about putting down a mini roundabout. And then in some locations, there are pedestrian and bike facilities incorporated within the design. And if you want to do that, we didn't specifically see any numeric value. All they said was a high pedestrian or bike volume. But there is just the one specific study that stated if you have 25 to 55 pedestrians per hour, that's when they implemented a mini roundabout. So that's what we saw in terms of the traffic conditions. When you look at the roadway conditions, mini roundabouts have been implemented at intersections on minor arterials and or collectors, okay? 2 lanes on the approaches, so one coming in and one going, and in very rare cases where these implemented on 3-lane roadways, okay? In terms of a speed limit, we're looking at speeds in the range of 15 to 40 miles per hour along that roadway or corridor that you want to consider for mini roundabouts. The existing intersection control should be stop controlled, either always stop control or two-way stop control. So you're basically transitioning from an all-way or a two-way stop control to the next level. Now, instead of making the jump to a signalized, you're actually finding something in between, which would be a roundabout. In some cases, intersections that have been previously signalized, but recently they did a signal warrant analysis and it didn't meet the signal warrant criteria. So then you're also thinking about a mini roundabout or a traditional roundabout. When you're looking at the approaches and the intersection of these approaches, the minor and major approaches, for most applications, you want them to intersect at 90 degrees, and rarely have minis been used in skewed intersections. Okay. Additionally, we saw a lot of these applications on 4-leg intersections and very rarely on 3s. If there were any 3-leg applications, there was a chance or likelihood that the 4th leg was for future construction. Okay. And for the most part, a lot of these intersections had limited right-of-way. So there was a lot of existing stuff going on the outskirts of the intersection, and there was no way for any expansion. In terms of, do you place them within a corridor or not? Outside of the urban areas, mini roundabouts were recommended in isolated locations. Okay. So these were the roadway type conditions. And then of course, there are other conditions there in place as well. In places where there's an observed unsafe driver behavior, lots of left turning at the intersection, a lot of running stop signs, excessive speeding, that's where these mini roundabouts were implemented. In areas where there's evidence of obstructed or restricted sight distance at intersections. So I'm sure you're familiar with places where they have an intersection and then they have maybe a bunch on each corner of the intersection, they have gas stations. In those type of locations, mini roundabouts were perfect. In places where there was observed congestion and the presence of long queues, we saw a lot of implementation of roundabouts. Michigan has a number of them. Reported high frequency of crashes and crash severity. Again, you're placing these roundabouts to reduce fatalities and the number of injury severity crashes. At or near direct accesses or intersections where turns into or outside of roadways are prohibited. So where you have a lot of driveways close to the intersection, it was a great thing to use mini roundabouts. So these are the roadway, traffic, and other types of conditions that will allow someone to think about mini roundabouts as an option for that intersection. Okay, if you have any of these conditions, you might consider mini roundabouts as an option. So in terms of the physical design of the roundabouts, in terms of the inscribed circle diameter, right in the which works or ties with the availability of the right-of-way, we were talking about a 90 feet maximum with a 40 feet minimum ICD. Desirable dimensions are in the 70 to 80 feet range. Okay, the central island we're talking about 70 feet maximum, 15 feet minimum, with a desirable dimensions of about 45 to 55 feet. The central island should be such that it causes a deflective path for the entering vehicles. So one of the things we heard from the engineers and also saw in some of the videos that were available was that drivers have a tendency of just going straight through these mini roundabouts. So you want to create the central island such that there is that deflective path, and drivers are really adhering to going through that counterclockwise circulation. So how do we do that? Typically, you want to raise that inner central island by 5 inches maximum, 2 to 3 inches being the common dimension that was used. And you also want to, it's recommended that it has a domed shape, so about 2.5% cross slope from the center going outwards, okay? We saw a lot of the central island being painted. So if you go to the UK, they just paint it white. We've seen use of people using their logos. So if your city, your county has a specific logo, or if the mini roundabout is close to a school, then you can use the logo of the school to colorfully paint the central island. We've seen brickwork being used. We saw stamped concrete also being used. Lots of different things that people can use. The idea is when it is raised, you want to make sure that high gross vehicles, emergency vehicles can easily go over it, especially when you're talking about snowplows in the area, if you're in a location where you have lots of snowfall. Okay, so you want to keep that in mind. The circulating lane width, we're talking about a minimum of 12 feet and a maximum of 20 feet. The desirable dimension is between 15 to 18 feet. The entry lane width, you want 15 feet maximum with, again, a desirable of 12 to 14 feet and a minimum of 10 feet. You don't want to go lower than 10 feet, okay? Approach speeds, again, we're talking a minimum of 10 miles per hour, a maximum of 25 miles per hour. Desirable, you want to be in the 15 to 20 miles per hour range. You want to make sure the cars slow down so they are able to deflect and go around that central island. There are design specs on the split island, both for the major and minor approaches. So they have different split island lengths, and we're talking about 200 feet maximum for the major, 150 feet for the minor. You can also have them the same. It's just depending on how you want to design it. So there's no hard and fast rules for that. The split island width, you want a minimum of 6 feet and a maximum of 20 feet. Depends on how much right of way you have. The desirable was about 10 to 15 feet, okay? And the split islands should be provided on all approaches to separate the opposing vehicles. You want to make sure you separate them. You want to make sure you provide that deflective path, and also you want to increase the conspicuity. One problem we saw even from the simulator was some drivers did not realize that they're going towards a mini roundabout, and so you want to increase that conspicuity as they get to the circular area. Pedestrian crosswalks. So you want to recommend, the recommended width was about 8 to 10 feet, which is typical of our crosswalk widths. They're usually included within the split island so that they can make a transition as they cross the two lanes. Pedestrians can make that transition. And you want to include enough for a single vehicle to wait to enter the mini roundabout. So you want that to happen as well. When you talk of the design vehicle, we looked at the international standards. We looked at what people are using here in the US in terms of the pilot projects. The recommended design vehicle for mini roundabouts is a standard passenger car. In some locations, like a school zone or something, buses have been accommodated within the design. Anything larger than that, you're trying to avoid a mini roundabout. So if you have high truck volumes, you might want to consider not putting in a mini roundabout, because I know I've seen some videos from Michigan where big high gross vehicles, semis, have been able to maneuver a mini roundabout, but you don't typically expect those trucks to be there, okay? Especially if those routes are frequently used by large vehicles and you're trying to avoid that. When you look at the construction, and most of these mini roundabouts are constructed in a similar manner as traditional roundabouts, the same materials. You're talking about asphalt concrete and other paving materials, a composition of brickwork and things like that. So it's the same stuff. The costs on average about $150,000 for a mini roundabout. So very cheap construction. And then because of their smaller footprint, there is a group of people, it's called Vortex Engineering. They have started to spearhead development of modular versions of a mini roundabout. Okay, so you're basically using recycled plastic materials and making pre-drilled blocks or modular pre-cut blocks that are being used for mini roundabouts. So what you see here is an application in Virginia. So this is good because you have shorter timelines in which you put the modular roundabout in place. They do not require any long-term work zones or anything like that. The issue with this is you'll need to pre-design this roundabout, send the drawings to Vortex, and then they will prefab this roundabout for you. So there is an issue with how fast the construction takes place, and the actual pre-cut modular blocks are brought to site. The costs greatly depend, again, on the specific design and will vary from location to location. Now, we did see modular versions of in the European market. An example is Zipper. Basically, and I think you can see my my mouse there, but you're basically putting some curved kind of pre-cut blocks, and then you just design the roundabout on site. So this was another version of it that we saw in the market. And at this point, I will leave it to questions.
Yes, we have two questions for you so far.
Sure.
First one is, if northbound and southbound volumes are 65%, approximately 65%, and westbound is approximately 30%, and they have done SBLT approximately 5%, how will there be adequate gaps generated in northbound traffic for westbound traffic to enter the roundabout?
Say that again.
Sure. They said if the north and southbound volumes are approximately 65% and the westbound's approximately 30%, and then they had put down SB, which I meant take to mean southbound, LT, approximately 5%, how will there be adequate gaps generated in northbound traffic for westbound traffic to enter the roundabout?
When we did the simulator and simulator study on this mini roundabouts, what we saw is the gaps really don't matter because drivers are actually using the same gaps that have been traditionally seen for the common roundabout, the modern roundabout. So they're using the same 3.8 to 4.2 gap, seconds of gap. So I don't see any problem with the gaps.
Okay, the second question. It appears that the design specifications presented rest entirely on the study of the design of existing roundabouts roundabouts, not on the study of their safety, meaning crash reports, or observation of operation, speed, maneuvers, and conflict analysis. Is this correct?
So we did the design, yes. What we shared right now is basically on what has been implemented. We did also do a microsimulation assessment of some of the geometric features, and I'll share those results in the coming up slides. So there was an assessment based on safety and also on operations. Now, I will make a note there. These are simulated versions. We really don't have data from the actual roundabouts that have been in place in the real world.
We have one more question before we move on. Was there any evaluation on preferred bus percentages? Were they accommodated on the roadway or allowed to turn over the mountable portions?
No specific study on what the bus percent was, but they were included as high volume, on large vehicles. So we're talking about 3% or 4%, including buses and trucks. So if you have a location where you have 3% or 4% truck volumes, including buses, then you should be fine using a mini roundabout.
That's all the questions for right now. Thank you.
Okay, I'll go ahead. So the second part of this study, we looked at a survey of practitioners. And the reason why we did this survey was we wanted to find out what people that have implemented these roundabouts or have an idea of mini roundabouts, what were their thoughts. And what we really wanted was to identify what important factors they used in adopting mini roundabouts and what they think we should be thinking about as we implement these roundabouts in the future. So we developed a survey. We sent it out via online format. So it was a Qualtrics survey. We had a bunch of questions related to prior knowledge of traditional mini modular roundabouts, the reason why your specific agency installed the mini roundabout, and other different questions. We did it through a Qualtrics platform. Thanks to the Ohio LTAP, they shared a list of people that we should share the survey with, and then we basically got 92 responses. 52 of those were Ohio-based, and the map there just shows you where some of the states that responded. A lot of them were in the northeast there. Florida did, and a couple from Washington State and from Utah. So some of the findings of our survey were basically there was a reasonably high level of familiarity between the respondents. So all the people that responded to our survey were kind of familiar with the use of or design of mini roundabouts. Several agencies used minis as alternative in locations where traffic signals were in place as well. And then the traffic signal, again, after a signal warrant analysis, were not warranted. So they used in those cases as well. The respondents mentioned negative public perceptions prior to the installation. So very similar with what we have observed over time with the traditional roundabout. People don't really like them. I deal with roundabouts. I get a lot of people calling me about how bad roundabouts are, but over time they start to realize the positive side of roundabouts and the opinion changes. So it's similar things we heard for mini roundabouts. The major concerns that a lot of the transportation professionals and respondents for our survey mentioned was the fact that because of the smaller ICD, a lot of the drivers are neglecting the central island, and they're basically driving right through the central island, okay? And their fear was that because of that kind of a behavior, it's likely there's no point in putting down the mini roundabout. And then one of the bigger things they talked about was the difficulty with performing winter maintenance, so snow plows and things like that. So as you design your mini roundabout, you want to think about how best snow plows will be accommodated within your design. We looked at what factors agencies look at in terms of prioritizing the use of mini roundabouts. A lot of them, it was crash severity that popped up. Crash severity reductions, improving traffic operations, reducing the crash frequency. So those are the top priority items. And then safety-related improvements, basically, we want to reduce the number of crashes that we're seeing at the intersection. That's why we're putting in the mini roundabout, or even considering the use of a roundabout. Okay, so this just gives you an idea of some of the factors we had in our survey, and then which ones were top priority. You can see the first three all relate to safety. So safety is a big reason why mini roundabouts are being considered. In terms of where do they, or where have they used mini roundabouts, the respondents considered them on 2-lane highways, peak hour volumes of 1,600 to 1,800 vehicles. They reported the designs that they had in place were ranging from $150,000 to about $3 million. With most projects costing less than $1 million. So again, mini roundabouts are, of course, cheaper. Where modular versions have been used, respondents said they're advantageous for temporary traffic control. So if you're in Florida and your signals are blown down because a hurricane is coming in or something, then mini roundabout modular versions of them are a good choice to use. If you're in Ohio, Ohio State is playing a game and you wanted to transform some of your intersections so that there's a good flow of traffic, then mini modular versions are a good choice for that as well. Okay, and then again, just like we saw with our survey, our literature review, a lot of the agencies are just using what NCHRP 672 provide as guidelines for design of mini modular roundabouts. Okay, so that's kind of what we saw with the results from our survey. There are more detailed results in the report. Please feel free to look at that. Any questions?
No more questions right now.
No questions? Okay, I'll keep going then. So the other task that we did, like I said, we have a driving simulator and you can see versions of it. So what we wanted to do was just investigate what drivers feel as they navigate through these mini roundabouts. So what we did was we developed driving simulator scenarios. So we had mini roundabouts designed with different diameters. So we used an ICD of 45, 60, 75, and 90 feet, and then compared that with a single lane roundabout with 120 feet ICD. And then we had drivers come in and run through a bunch of scenarios. So we typically, what we did was we created 4 scenarios, daytime, nighttime, and then the presence or absence of pedestrians and bicyclists within the mini roundabout. And then as a respondent came in to drive the simulator, we asked them to drive 2 of the 4 scenarios, randomly selected the scenarios and asked them to drive through the scenarios. And they experienced each of the roundabouts. So they went through the 45, 60, 75, 90, and the single lane roundabout. And we observed different parameters. What critical gap were they using? What's the speed they were going through the intersection, exiting the intersection, and approaching the intersection as well. So we looked at those and then compared the differences and things like that. So we administered also a pre and a post-test questionnaire just to understand the perceptions of the participant in terms of, do they know what a mini roundabout is? Have they driven through one? Things like that. So we had 50 volunteer drivers. There was male drivers and female drivers ranging from the ages of 18 to 60 plus years. We have the specific statistics on the breakdowns of these numbers in the report, so you can look at that. But here are some of the results of what we saw in terms of the simulator experiment. So when you're looking, what we wanted to see was the critical gap. And if you look at this chart here, it basically gives you the critical gap overall, daytime scenarios, nighttime scenarios, female versus male, and then the different ages by the intersection, the specific ICD for the mini roundabouts. Okay, so you can see that here. Overall, what you see is that the critical gap does not significantly differ between the mini roundabouts. Okay, so it ranged 4.22 to 4.82 seconds. I know in this chart you can see differences, but when we did some statistical analysis on these gaps, there wasn't any significant difference. For mini roundabouts with an ICD of about 60 feet, the critical gap was very comparable to that of a single lane roundabout. So we're looking at about 4.11 seconds in terms of the critical gap. And then generally, the critical gap was longer during the daytime driving than nighttime driving. And this is expected because it was easier to become aware of the difference between the roundabout sizes. Okay, so drivers were able to perceive the mini roundabout and get a visual of how big it was versus how small it was in the day than in the night. Okay, so lighting might be something you want to put down as you design your mini roundabouts. Okay, and then when you look at the observed speeds, and what you see in the pink side of this is on the approach, so 500 feet away from the mini roundabout, and the speeds as you approach the yield line. And then the circulating area is that yellow piece, and then the green side is as they exit the roundabout. So what you see here is in relation to the single lane roundabout, which was we used as a base or as a control. Okay, so you see that the trend in terms of speeds are generally the same. They're very similar trends. There are higher values on the entry approach, regardless of the ICD. So they're approaching at higher speeds. But then 100 feet prior to reaching the yield line, they start to slow down. And there was a 5 mile per hour difference between the different mini roundabout alternatives. Okay. Of course, within the circulating area, the speeds really dropped. And then as they exited, they started to speed up. So pretty much not many big differences in terms of the speeds between roundabout designs. When we looked at the pre and the post test questionnaires, a lot of the participants didn't have a lot of familiarity with the concept of a roundabout. And then there was a split between have we driven the mini roundabout or have we not? So one of the takeaways from this is that as you implement these mini roundabouts, you want to also think about education and marketing programs to make your drivers familiar with that. Any questions regarding the simulator study?
No questions on this section.
Okay, I will go through the microsimulation-based assessment then. So the microsimulation-based assessment, for the individual that asked the question, we went through 256 scenarios where we basically took SIDRA and VISIM, and we changed different ICDs, entry angles, and then major and minor volumes. We did different simulations and then came up and looked at measures of effectiveness to decide on which one was the best or optimal design of mini roundabout. So we found that the 90 feet ICD with an entry angle of about 50 degrees yields the best performance in terms of operations. And then we took that and ran it through VISIM. And with VISIM, you're able to get vehicle trajectories. So we took those vehicle trajectories and ran them through a software called SSUM. It's a surrogate safety assessment module, and we took those trajectories and saw what potential conflicts would occur. And we did a number of conflicts versus conflict types, and then ran simulations on which what's the most optimal roundabout design. So the results of these are all the different versions of the simulations and all are in the report. They're more detailed in there, but I will share very high level results here. And what we found was, in terms of operations, with larger ICDs, the performance was better. We found that the 90 feet with an entry angle of 50 degrees was the most effective. We also compared this with all-way and two-way stop control, and of course, the Mini was a lot more better in terms of performance. Safety-wise, a two-way major and minor approach volume of less than 800 vehicles and 400 vehicles on the minor was what you would want to design your mini roundabout for, and because that was reducing the number of conflicts. Okay, so the details of this are in the report. Any questions, Victoria?
No questions on that section. Nope.
Okay, so in terms of conclusions, again, mini roundabouts are excellent intersection control alternatives for Ohio's local transportation system. We had a bunch of criteria that people can use as a start to their designs. Of course, depending on what intersection and location, you'll have to tailor those minimum requirements. But we share, those are in the report. We also have site-specific considerations need to be in place. We based on the driver behavior. We recommended an ICD of 60 to 90 feet. Nothing less than 60 feet would be appropriate from the driver behavior side, okay? And then from an operational performance, again, an ICD of 70 and 90 feet with an entry angle of 50 degrees would be the most ideal in terms of control delay, queuing, level of service. And then we saw that you could recommend a mini roundabout where the major and minor approaches were in the 2-to-1 volume or less. And then, of course, there is a very big lack of knowledge among the public on how to navigate mini roundabouts. So as you implement these mini roundabouts, one of the things you want to do is create some public awareness through education campaigns or things like that. So that's kind of what I had in terms of this presentation. If there are any questions there, please fire away. Alternatively, you can reach out to me or Kakande at West Virginia University with any of your questions.
Okay, we've got some coming into the question box here. There was one person who asked about access to the report, and I did respond to them to let them know that we'll send out a link to that report in a follow-up email once the presentation is concluded. Another person said that the Wisconsin DOT now has specific design guidance on compact mini roundabouts for size 80 feet to 119 feet. So I guess that's more of a statement than really a question. The next person submitted, with these ICDs from mini roundabouts, any thoughts of ICD for 2-lane on all 4 legs?
I personally, I think mini roundabouts with single lanes are more appropriate than 2-lane ones. Approach-wise, we're probably looking at 2-lane roadways as well. Nothing more than that. We're seeing a lot of problems with larger sized roundabouts and 2 lanes. So I believe it will be even more interesting if we had mini roundabouts with 2 lanes in them. Will probably create a lot of crashes.
The next person wanted to know, what was the bullet CC minis at isolated intersections?
Say that again. What was the?
Bullet, and then they put in CC, the letters CC minis at isolated intersections.
I'm not. Do you have an idea where that was?
Jeff, if you can maybe follow up with some clarification on your question, that would be great. We'll see if he submits anything else.
Okay.
All right, and while we're waiting for Jeff to respond, just so everybody who might have joined us a few minutes late will be aware that there is a copy of this presentation in the handout section of the GoToWebinar panel. We are attempting to record the webinar, so if we're successful, we will send out a link to that. He said go toward the end.
Go toward the end.
I guess the end of your presentation.
Okay. I'm sorry, I'm flipping through.
You're fine. I'm going to see if I can find Jeff on here and maybe just unmute him and he can ask the question directly.
Sure.
Give me a second. Oh, he said page. Oh, yeah, Jeff, I'm going to unmute you. Hang on. All right. Found Jeff. All right, Jeff, I've unmuted you on my end. If you want to unmute yourself and ask your question through audio, that would be great. Just click on the microphone icon. He said page 43 low. There you go.
Not recommended to be considered for isolated intersections. So if you're in a rural location, you don't want to consider these mini roundabouts. And the reason why we said that was because in the rural locations, most of the roadways are high speed, and there will be a very good chance that drivers will not even adhere to that deflected pathway.
I live in the rural area and I could understand that. So. Yeah. All right.
So that's what we meant there. I hope, Jeff, I answered your question.
Yes, he said thank you. So
okay.
We're good there. All right. Well, there are no other questions in the question box. So thank you so much, Bhavin, for your presentation today and all the great research you have done on this project. And we will send a follow-up email out to everybody. Thank you for joining us. And we look forward to hosting you on a future research results presentation or webinar. Take care.
Thank you for having me.
Thank you.
Mm-hmm.
Bye-bye.